Start the recording and it's on. Okay, so this is where I should be. This is the exam review. Let me put the announcement date first. Okay. Two of the students are not here today. Obviously, they'd like to probably watch the video later. It's a little weird. Delino is missing. Arlen missed the class now and then. Delino doesn't do that. All right, so first of all, the final exam 3, I'm sorry. Exam number 3 does have two parts again, right? Take home and in class. So in class, take home. I actually wanted to do the exam on Wednesday because next week I'm leaving. You know that for Wednesday, right? It's all right. So I wanted to do it Wednesday so I can finish the grading before I go. I can still do it if we do it on Friday. So in class 1 would be Friday. Friday, what is the date on Friday? Today is Friday 10? Yeah. All right. So it'll be 4/10, 26. Okay. And in class 1 is 8, 26. Available. Okay. Take home on, sorry. And due on 4/10. So I have everything, like, I can start grading and everything. Okay. So in class 1 is like 40% points. Just one question. Just one question. And the question that in class 1 will have something very similar to what you're seeing it here. Okay. Just like the way you are seeing so far, right? In different exams, I do similar question here, so you don't feel like a stress during the exam. Okay. The take home, however, would be challenging problem. There are two problems, 60% points on that take home, right? So 2 questions. So in total, you would be solving 3 questions. Now, question is, what is the syllabus? Anyone remember? Is the chapter 14? Chapter 15 we're doing now, right? So chapter 14. Chapter 14, right? There's the syllabus. What did we learn in chapter 14? The highlight is, like, remember the energy. Joy, remember chapter 14? What did we learn in chapter 14? The highlights is energy balance. Remember that? All right. So in energy balance, what did we learn? We learned like kinetic and potential energy, right? Kinetic energy, we usually put it like what? TE, and potential energy PE, right? And then the kinetic energy is like very straightforward, half of mv squared. That's what you'd be using, right? The potential energy, two form, right? One for spring. Anyone remember the spring energy? Half of kx squared, right? And the other one is, that mgh, right? Something like that. So basically that is it. And other than this, energy of energy conservation or whatever, you also have to use, remember, what is the other equation you always have to use? Equation of motion, right? Equation of motion, like second law of Newton's second law, right? F equal to ma. You always use that as well, right? Remember that. So equation of motion. So these are the highlights. Equation of motion. So what will happen on Wednesday then? Wednesday would be continuing with chapter 15, right? There's a new homework uploaded in chapter 15. You've noticed this, right, everyone? Okay. Please explore that one. Why I'm feeling so many students are missing? Only 2 students are missing, right? 3. Oh, Christian is missing as well, right? Yeah. Now, how? Yeah. Suddenly, what happened to Christian? He doesn't miss the class else. He do sometimes try to them. Nowadays he started doing that. Oh, Arlene is here. Arlene, very good. There is some announcement. Okay. Take a picture or whatever, or this is on record. Watch the video lecture. I did talk about the exam. Okay. I'll just move on to this. Highlight the exam. Final exam is on Friday in class 1, and take home is available to you on Wednesday, and to you on Friday. Okay, the other thing I just talked about. Finals Friday. Sorry, exam 3. Why did I say? It does says exam 3, right? Nowhere it says final, so don't get confused. Exam 3. So exam 3 in class is on Friday, and the take home is. Let's move on. Okay, I'm giving you some time. I know some of you are started taking the notes and everything. You can definitely take notes. I don't know if I have uploaded it in Brightspace. Usually, I uploaded it pretty much everything in Brightspace. This one, not sure the 100%. But as long as you have the sketch somewhere and the givens, then you should be understanding the problem, what is happening, and you would be getting this question anyway on Friday. Something similar, not this exact same one. Okay. Okay, so that's the take home. Sorry, in class one. Okay, so let me start reading the problem. So if the spring is compressed initially 3 inch against the 0.5 pound block and it is released from the rest, right? Determine the normal force of the smooth surface on the block when it reaches the point x equal zero point 0.5. So see the block here on the slope, Joe? So it says here the x value here is 0.5. Make sense? So you see this is your 0 point. You agree, Joe? Okay, so x is 0.5 here. All right. So if you know the value of the x out there, can you find the value of y at the same point where the block is? Again, the block is here, right? So the value of y would be what? Anyone? No, no one. You just have to use this equation, right, Brody? Half of x square, which would be I had it solved here. Let me write it. So which would be 0.125. Or maybe write the whole thing. So you have 0.5, 0.125. Okay. Feet. By the way, this is feet unit. This is the English unit problem. All right. So what else? This block itself, as you can see here, block itself is 0.5 pound. All right. And y is actually h. You can say it is h, right? It's the height because mgh people use for potential energy. So you won't be getting confused. That's why I'm just putting it as a h. So spin potential energy at this point B. Can you guys have any idea? So this is your spin potential energy at point B, which would be TB, right? Half of k x square. Now, what could be the value of x here? Anyone? For the spring at position B? So it released from rest at B. So your B is here, right? And then it was compressed at point B. How much? 3 inch, right? That's not the length of the spring. That's the amount of compression on the spring. So that's your x value, right? So this x and the other x in x direction could be confusing. You may want to put like a subscript like b or something. That way you won't be confused, right? So and then you may start solving this thing as a engineering format, a little bit standard way. So givens should be what, like the mass of the block m is 0.5 pound, right? And then the spring compression distance, so xp is 3 inch. Yes.
Would it be weight for the block?
Yeah, that's 0.5 is the weight for sure. But if you need to use, like, you can obviously get it in slug by dividing by 32.2, right? That's the mass. But this also people refer it like pound mass.
Yeah.
pound mass. Okay, so you can still say like 0.5, and in that case you gotta write m here as a subscript. But if it is a load or like the force itself or weight, whatever way you want to say, then you should be writing pound force lbf. Okay, but again, if I'd like to get it mass in slug, you have to divide it by 32.2. Okay, that's the relationship. Anyway, so xb is the spring compression. You may want to put some note here next to it, right? So it's like spring compression. So spring compression. This is the only problem we'll be doing, because that's a very similar problem in exam review. What I'm doing is the in-class problem you'll be expecting. Okay, so I've been going really slow. Make sure you understand each and every line, everything that you're seeing here. Okay, if not, then just don't go. Stay here. I'll make sure you understand before you go. Okay. So spring compression, right? So this is your spring compression. I'm sorry, this is a little congested. Hopefully you understand. That's the compression. I can write it in next line if you want, but let me know. Your choice. All right, so then the distance travel is what? From 0 to x value 0.5. We've seen that, right? We've found the value of the y as well, which is h. I was saying that. So let me write that distance traveled. So distance traveled. I think I put 2L. It should be 1L, right? Distance traveled x is 0.5 feet. So there's a difference. Like, I had the 3-inch before. You actually should be dividing this thing by 12 to get it in feet, right? You know how to write feet and inch, 1 line, 2 line on the top. All right, so double inverted comma, single inverted comma, whatever you want to say. Then the spring constant is given as well, right? So spring constant. Usually it refers by K, and the value of K is 5 pound per inch. All right, so what you are trying to find here, see, take a look here. Determine the normal force of the smooth surface on the block when it reaches a point X. So you definitely need to find a force. So find the normal force and at what? At X equal to 0.5 feet. Okay, you may write an equal question mark, so that can clarify this concept even further. And then obviously you would like to add something here, like, as a free body diagram, when the block is at 5.5 feet away, right, on the curve itself. So you may first, I'd say, like, draw the block. Okay, so you have this block like this, right? Okay, and it's on the curve. And then this block, if you're gonna start to put like some of the axes around, right, around the block, which does have an angle, by the way, and this angle value is did they give you the value of the angle? All right, so they didn't give you the value of the angle directly, but you can able to find that value of the angle. I thought they gave you the value of the angle. Did they? No, they didn't. Okay, but we can find the value of the angle. Can anyone give me a clue how you can find the value of the angle? The tangent of y and x. Y you just find 0.125, x is 0.5. You should be able to. Joe, you can find the angle. How I'm saying that? Okay, take a look here. Okay, I'm gonna be using a little different color, just to delete the angle. So I don't know. Do you remember? I had this angle is theta, right? And I have this x is 0.5 feet, and I had this y equal 0.125 feet, right? So the angle should be 10 theta, y by x, right? So 0.125, 0.5 feet cancel out. If you're going to do the math, you should be able to find the angle theta. Anyone can give me the value of the theta? I do have it here, but you should be finding it by yourself. As you can see, this problem is a little extensive. If you didn't do it here before the exam, it could be confusing during the exam. This problem has so many dimensions, and I just started. It has other stuff as well. Okay, we got to do the energy balance. We got to do the equation of motion. Ultimately, our goal is to find the normal force N. Okay, from equation of motion. But what is the angle theta you found?
14.
Huh?
14.
How come?
I got 14.04.
I did some mistake. I have, for some reason, it's 26. And I don't know, I didn't calculate it here in my notes. But if you're finding it, okay, what about this? Is it 0.125? So 0.5 square is what? 0.25? Is 0.5 square is 0.25?
Yes, 1.125.
That's 0.125. I have it in note 0.125, but this one I don't know. Everybody wanna verify? Is it 14? Why I have it 26? I'll take 14 if it's 14. Everybody finding it. All right. So the point is here. Let me go to the straight to the point. Okay. So you do have this force. Okay. What is this force, by the way? That's the weight, right? So that's 0.5. That's your 0.5, Joe. Okay. And then what is this? That's the normal force. What is this angle? Is this theta? What is this angle? Is this theta? So this theta doesn't look like a theta. Let me make it clear. Okay. I can do it. It's all right. So I'm saying like, okay, this is theta, right? And I'm saying, okay, this one is y 0.125. All right, now it's more clear. All right, so now we have something that we want. Okay, so now this 0.5 does have two components, right, Aline? One is along the normal direction. Which one would be? Another one would be the x direction, right, along the slope curve. So one would be this direction, right? Another one would be this direction. So this one would be 0.5 cos of what? Theta, which is 14, you guys are claiming, right? And this one would be what? 0.5 sine of theta. We are not interested for the sine of theta. We don't need it. We just need the cos of theta because the normal force that what we're trying to find, right? So we just need to do the equation of motion in what direction, like in the y direction or x direction? Definitely in y direction, right? I didn't understand so far. This one is a very comprehensive problem. It does cover everything on chapter 14 that you guys learned. Everything. And some more with the geometry or angle is there. All right. So now that you have pretty much everything, okay. So there's two things that you can do. Okay. First is before even go to the energy equation, like you may not know like why you need the energy equation because the question is asking with the question is asking what? Find the normal force, right? So to find the normal force, if you want to do equation of motion along the y direction, right? So can you find the force along the y direction? I mean, if you know the tangential acceleration, you can, right? Because take a look here. I mean, you can't straight tell like in y direction there is no force involved. There is force involved because along the normal direction. Because I need to understand. So what is happening? The block that is going like this, right? So it's not a straight line like this or that. So along the y direction, normal direction, the block is moving, right? This is following a it's following a track, right, which is the curve. Okay, so now to find by doing the equation of motion, equation of motion is what? Like along the y direction in left side, you have all the forces. What are the forces? Like the normal force and the weight force in y direction, right? In right side, when you have the resultant force, where the block is actually moving, right? Which is m multiplied what? An. Along the normal direction, the resultant acceleration. Everybody agree? You understand, Joe? So in the left side, we have all the forces, like the normal force and the weight, y component of the weight, right? The left side. Those are the forces. In the right side, you have what? Like the block movement, right, Brad? So the block is moving in tangential, normal direction, right? So like m a n, that's the normal direction acceleration, right? That's the right side. So now, anybody remember from last exam? Actually, from even first exam, what is the normal direction acceleration equation? There are two different acceleration, right? An and at. An is the normal direction. V square over rho, right? What is rho? Radius of curvature. Do you know the equation for rho? I mean, you may have forgot, but that's a complex one, right? It's a second order derivative that you gotta deal with that, and everything you gotta deal with it here. That's why I'm saying this problem is kind of covering everything you learn and some more, like the geometry as well. Okay, so this is extensive problem. That's why you'd like to pay your full attention here. What is going on? So you'd like to find what the equation of motion. Let me write it here. I'm sorry, I don't want to use this color. I want to use the black color. So equation of motion, right? Equation of motion along which direction? You can say y direction or normal direction, or you can say along normal force direction, right? Okay, I don't want to take the class. That's so important. You have to do it in class. Like there's an exam. Okay, so then you have this normal force. If you can assume now, again depends like which direction is y, which direction is x, right? Here, if you're gonna assume, right, that's something I'm doing here. Okay, so if you're gonna assume this is your x prime and this is your y prime, right? I didn't put look into it. I didn't put x and y because I already have x and y, right? This is the prime. Do you understand? So now, if you're gonna put it this way, obviously you'd like to do like summation of fx and summation of fy. If you're gonna do summation of fy, right? You can do that, right? And y prime should be equal to what? M A N, and that's the important thing to understand. Why is A N? Because when the block is moving on the track, right, and y direction is the normal direction. Does it make sense? It's a little tricky to understand that part. So I'm just saying, like, say like this is part of the track, right? And your block is here. And you can think this way, okay? This is the normal direction, and if the curvature, radius of curvature is rho, right? If this is your normal force, does it make sense? So this AN is going on that direction, right? So basically AN is acting on this direction, right? Make sense? All right. If that's the case, then you're kind of very close to dealing with this problem. So here on the left side, you have what are the forces in y prime direction, right? You have the normal N, right? And it should be positive, right? It's going up. Where is the other force? Is the part of the weight force that is acting down. So you should be putting negative. And what would be the value of that? Cos theta, right? 0.5 cos theta. And this M is like 0.5, right? Just the mass. And here's this thing comes, like, Joe, you pointed out. I mean, can you put like pound here? No, you got to do it in slug because you have AN here, right? It makes sense. So don't worry about the units. I'm going to put it shortly. So this whole thing is in pound, right? And this thing needs to be divided by 32.2 so you can get it in slugs. And that's where the problem happened, right? The things get a little complicated. So, and this AN is V square over rho, right? Where maybe you'd like to put a little bit note here, right? So where AN is what? Normal direction acceleration. Okay, that's the AN, right? All right, so then this rho is radius of curvature. This rho is called radius of curvature. Now I'm going to give you the equation shortly. Radius of curvature. Here's the problem. Actually, two problems. First, I don't have the value of the radius of curvature directly. Neither do I have the value of the v or velocity. Okay, I have everything else. Like you guys had the value of the theta 14. I don't know how you got 14. I got to make sure it's really 14. I have it 26 in my notes. But other than that, you have to find the value of the rho. How are you going to find it? Anybody remember that equation is a complex one, right? So let me write that equation. So the radius of curvature equation can be written as 1 plus dy by dx. Okay, the whole thing is square. That means you are doing the derivative just one time, right? And making the result square. Okay, that's a little tricky to understand. You're going to understand it much better if you understand the denominator. What did I write that denominator? Arlen? Is the derivative of one time or twice? It's a second order derivative, right? Because you have, whenever you see that means you are doing the result of the derivative again another derivative. Okay, whenever you are seeing this, that means you do derivative just one time and the result you are squaring it. Okay, I know Arlene, you are taking this calculus now. You guys, Arlene, you have seen this kind of thing before in calculus? You're seeing it now. Okay, perfect. So, ask your instructor or a math tutor. So, show them this equation, rho, the radius of curvature equation, and you may talk more about them, to talk more about this with them. All right. So then you have this first order derivative and the second order derivative. Now the y equation was given, which is y equal to what? What is that? Half of x squared. So now it's the time for your test. See if you can deal with this derivative. You're going to do the derivative twice where the y value is given as like half of x squared, right? So you're going to do the derivative for first time, which is dy by dx. Joy, can you do that derivative? So, y equal given again what? Half of x squared, right? So 0.5 x squared. And your ultimate goal is to find the rho, by the way. And you should be able to find the rho value. I'm giving you the value, final value, which should be 1.398, right? And the direction I'm giving you for all of you, right? If your y value is given, which is half of x squared, right? Then you can write this thing even much more simpler, 0.5 x squared, right? Then do the derivative dy by dx. Okay, and then once you have the result, I'm not going to obviously give you the result right away. I'll let you do that. You do the derivative again one more time. Okay, the reason I'm writing it this way, this is the same as dy dx, dy by dx. Means once you have the result of dy dx, you plug it here, do the derivative again. Okay, does it make sense, Joe? All right, so once you did everything, you should be finding 1.398. Unless if I do something wrong with my notes again. You guys had 14 and I had 26. That kind of trips me off. Maybe something else could have issue.
Is x 0.5?
The x is 0.5. Yep. X is 0.5. Y value you already have though, 0.125. But you actually would like to do the derivative first, those two things, and plug those values here, and then plug x and y value. I don't think you will have any y over there once you do the derivative because y equal to half x squared. So you're gonna do the derivative of. I mean, you should be able to do the derivative. Like this is the basic stuff because this y is like 0.5 x squared. This is the y. So if you're doing the derivative one time with respect to x, right? This 0.5 is 0.5. That's a constant. And this one x squared. What is the derivative of x squared? So see, think this way, x to the power n. So the result of the derivative is usually x to the power n if you're going to do n multiply x to the power n minus 1. So here x is n, n is 2. So you should be writing 2 multiplied x to the power 2 minus 1. 2 minus 1 is what? 1, right? So it should be what? 2x, right? You got 2x? Oh, you got an answer already? So is it like x? Oh, this one on here, you already got it? It's the same thing, very close. How did you do that?
It's an 8 up, but it's 7. So 1.397.
you should be when you get in detail, right? Okay, so this one is like x only. And you should be doing that again separately. So and then plug the value. You find the value, Logan, the same value, 1.398. What's got that 1.398? You're getting it as well, Alicia? Joe, you getting it? Got it?
Almost. What's in front of the first character?
So just one.
Almost out there.
I'm sorry, yes. Overriding happened over there. In the numerator, you have 1 plus, okay? You're getting close then? All right, doing math is fun. All right, so here, okay, so first of all, this would be like, 0.5, right? And then 2x. So basically that means x. And if you're going to do the derivative of that thing again, x, which would be 1, right? So then the row can be written as 1 plus x squared 3 by 2, and the denominator is 1, right? Is that everybody found the same way? So 1 plus 0.5 square, right? 3 by 2, and this should be in feet unit wise, and then you have this 1 and this whole thing is in feet, and you should have 1.398. Does it match it, everyone? That's the row value. Is that how you guys found it? Okay, perfect. All right, so now that we just overcome a major hurdle, I'd say, right? Because the row was found, right? The AN, can it be found? No, there is a problem. The V or velocity needs to be found. Where you can find this? From the energy equation, energy conservation equation, whatever you want to say, does have like the kinetic and potential energy, right? At point A and point B. I shouldn't say point A, point B, and this new point wherever my block is, like at x equal to 0.5. They have the point A is at the top. Okay, so I don't know when that, maybe that point can be said like point C. Maybe this point we can say this is location C or something. Okay, all right, so point B and point C. So you want to do kinetic and potential energy, right? Summation of kinetic and potential energy at point C and point B. Can you do that to find the velocity B? Now here's the clue. So at point B, it was at rest. Does it mean that it doesn't have any kinetic energy? Because half of mv square v is 0 at point B. Okay, it does mean that. So at point B, there is no kinetic energy. At point B, is there any potential energy? Now it depends. If you think the datum is over there, there is no potential energy due to height, but there is a potential energy due to the spring. And you know spring potential energy, I did write it already, right? Half of kx squared, x is 0.3. And that's all about point B. What about point C? At point C, it does have all of these things, right? It has the potential energy, it has the kinetic energy, right? So now come one by one. Okay, first is the kinetic energy. At point B, think this way. What is happening? The spring with this block, right? It is compressed first at point B, and it starts from that point, and then it slides along the curved path. When it does slide along the curved path at point C, it does have a height, right, compared to the point B. So that is the h or y, which you found 0.125, right? So because of that, you have a potential energy, which is mg, that height, mgh. Do you agree? So that's at point C, like the potential energy. At point C, because it's moving, right, along the curve, so it does have a velocity, so it has half of mv squared, right? Half of that's the kinetic energy, and that is the v that you should be plugging in here. Okay, Alan? That is the v, that the v I was talking at point C, the velocity, that is the v you should be plugging here. So see, you kind of get the idea. So you gotta do the energy balance to find that v velocity, which you'll be ultimately plugging it here to find the value of what? M, the normal force. How many twists here? You started everything by finding the value of the theta angle. And then you did the energy, the equation of motion equation in y direction, and it's not like you get it directly. There is the other axis system, x prime, y prime you have to do, and then you write everything, and then you struggle with this rho again, the radius of curvature. Then you have to do the derivative twice, right? And then you find the rho somehow, and now you struggle with this v. You don't have the v velocity, right? And now you have to go to the energy balance equation, right, to find that v. And again, it's not straightforward because you have point A, point B, and point C. On C, it's very complicated problem. I have to cover it here, and it does cover pretty much everything that we learned, right? And it is a very comprehensive problem. 40 points is there. If you're going to do that math problem one more time at home before the exam on Friday, right, you should be all right in exam. Okay, you shouldn't lose any points during the exam as long as you do it another time. All right, come back here. So you'd like to do one thing though. You'd like to make it as equation number 1, right? And then you would like to explore this energy balance equation. So we should be doing energy balance equation. That's why I just have one problem in exam. Okay, in 1 hour you'll be solving this, just this, very similar to that, whatever you're doing, just one problem in exam. Okay, and very similar to whatever you're seeing it here. So energy balance equation, you have like this at point B, at point B and C. Okay, so you have this TB plus BB. You remember that capital B? What is the capital B? T is for kinetic and B is for potential energy, right? That's the symbol you guys are using. So that TC plus BC. Now, it is started from the rest, so it would be obviously 0 at point B, right? And then you have this half of kxb squared, right? That's the spring energy. And now you have to understand the datum. What is the datum? At point B, right? So that's why you don't have any potential energy at B. Excuse me. Sorry. Just 1 second. Oh. All right, thank you. T is the potential energy or kinetic energy? T is the kinetic energy, right? So half of then MB, you can see BC. If you're going to write BC here, you should be writing BC subscript here, right? It depends how you want to write it. But I'm going to stick with this C, BC. All right, so then that's the kinetic energy, right? And then you have this, half of mgh. So mgh, right? And then the spring energy at point C, we'll be assuming is completely stretched. There is no spring energy left. Okay. So that's the idea at point C. So if that's the case, there is no spring energy. If there is a stretch happen, or if still there is compression, you got to add the spring energy. So you're assuming at point C there is no spring energy. Okay, you will understand this, right? Let's say you got it. So if point C, the spring is at regular shape, right? So it doesn't have any compression or stretch. That means there is no spring energy involved. Okay, everybody's good, right? On that concept, it may be confusing, the thing that I'm doing on the right side. Okay, then you'd be just plugging all the values. So you have this half of, what is the value of the K? 5 is what? Like, 5 pound per inch, right? Are you dealing with anything in inch? No. We are dealing with what? Feet, right? So 1 feet. So that's another tricky part on this problem. Just make sure you convert everything in feet. And then the XP is given as well, right, in inch. So you're converting it to feet. You want to do a square here, right? So feet square, half of kx square, right? Or that's the amount of compression happen on the spring, by the way, when it's at point B, equal to half of, now this m, what is that m you want to write? Is it like 0.5 you want to write, or you want to divide it by 32.2? You must want to divide it by 32.2. 32.2, and then you have it slug, right? And then this BC square, and then plus this mg, the whole thing can be written as 0.5. Can you write it? 0.5 force. That's the pound force, by the way. Right, Joe? Isn't it confusing? See, 0.5 is the pound force, right? Then you don't want to multiply with G 32.2, right? If you have the m is in slug, then you want to multiply it by 32.2. But is the m is in slug in this case, 0.5 is the pound. So you don't have to multiply it again. So see, in two terms, one time we divide it by 32.2, another time we're multiplying it by 0.5. Yes. Yeah, so the 12 inches is here. I'm dividing this here. Oh, that's the 12 inch. Yes, that's the 12 inch by 1 feet. Why I'm doing this? Because this spring constant is given as pound per inch. Okay. All right. So then what? This 0.5 is so important to understand. And you are multiplying this thing. What is the h value, Brett? 0.125. 0.125 what? Feet? Yeah. So in this part, this is a complex math, right? Seems like apparently. But if you're going to do everything, you should be able to find the value of 15.4 and let me know if you get the same value, feet per second. And then all things left for you to plug the values of this velocity b. By the way, I should be putting a bc subscript, right, at point c. Okay, so all you got left to do after this point, you got to plug this value of the bc here in this equation number 1. Okay, that bc you're seeing on the right side, and you will apply the value of theta, which is, you guys are climbing 14 point something. If it's 14 point something, I don't have a result for n. If it's 26 point something, I have a result for n, which is 3.08 pound. Okay, but obviously everybody got it 14 point something, so I have something wrong in my notes. So what do you want to do with this one? You want to do it one more time at least before coming on Friday exam. I'll suggest you do it on Thursday. Okay, if you're gonna do it as well right away, then you may forget what happened. By the way, these notes that you are taking now is allowed on the exam, so should be all right. Okay, so make sure to take the whole notes. And as I'm saying, keep saying that same thing again and again. If I'll be in a position, I'll be doing it one more time, even though the notes are allowed, one more time on Thursday. I don't leave it like this. It's a very comprehensive problem. It covers pretty much everything that we learned so far on that chapter. Okay, let me know what is the value of the n, because I do have a different value of n. Okay, so what I'll be doing, let me just move some of the things. Okay, so I'm just saying like the BC value. What is the BC value? Everybody found the same BC value I have? Is it 15.5? 15.4? All right, so then you would like to plug in equation 1, plug BC and theta. And then you should have n, a normal force that you would like to find, right? So n minus 0.5 cos theta equal 0.5, 32.2. This BC is 15.4 square. This rho is 1.398 feet. This one is feet square divided by second square, right? And this one is slug. Okay, and then this one is in pound. Okay, so then this n value would be, anyone have a value of n yet? 0.5 cos. What is the theta value found you guys are claiming? 14. All right, 14. You guys make sure it's in radians or in degree when you find the value of the theta. It is in degree in your calculator? Okay, it's fine. So, huh? In degree. Okay, perfect. All right, so then you should have this 0.5, 32.2. Okay, I'm skipping all the units. I'll just simply write the pounds for one time. 15.4 square, 1.398. That's the trick. Sometimes I do the whole thing. I know is in pound, right? So I can write it this way. And then what is the value that you guys found? Anybody?
I got 15.3.
15 point. Huh?
Yeah.
We got 3.1.
I don't think it's 15. It should be 3 point something. So 3 point what?
3.04.
Huh?
3.04.
3.04.
That was
What else you have? I have, so 3.04. What else you find? 3 point? 1.2. Anybody else?
Yeah, I got 2.11.
2.11 is not correct. It should be that one. Anything else?
No.
I got 3.1.
I got 3.1.
3.12. That sounds like correct to me. Okay, Aline, you got to check the calculation one more time because I have 3.08. Okay, so it should be a little bit, on the other side. Okay, no, it's okay. Here's the thing, Aline. I know what you're trying to point out. Okay, it doesn't really matter that much of a small difference. It doesn't, but it's the technique or calculation that you're doing. Is there anything wrong? You guess the value of it. The calculation.
3.12.
Anyway, so that's why it's so
3.085.
important. Okay? All right, everybody's good so far?
I don't know. It's whatever.
Okay.
Close enough.
Okay, 2.11, I'm not sure, but I'm putting a question mark on the other one. But this is my opinion. 3.12. I gotta do my calculation myself. I can possibly do it, and I'll see you on Wednesday. Yeah. All right, guys. Sorry, I took a little long time today. Usually it does end well early. Maybe on Wednesday it will gonna end well early again. But on Friday again, it will be full class. See how bright and sunny today.
That's
Enjoy
Friday
the day.
or
Huh?
Wednesday?
Huh?
That's Wednesday or Friday?
No, Friday. It's a little bit better. Wednesday is like the take home one would be available to you, but not that. All right, I'll send an email again on Wednesday. I guess that will clarify things even more better. Okay. All right, Alyssa, Arlene.
That is still a different answer. Like I got like 3.08.
Should I stop here? You guys are good?
Yep.
All right. You have all the notes? Alyssa, you're good?